Hello everyone. Today we are going to discuss lecture number 11 of single phase induction motor. In this lecture we will see how the pulsating magnetic field of single phase induction motor can be made rotating by using two theories. One of the theory is double revolving field theory. So starting with this theory uses an idea that an alternating uniaxial quantity can be represented by two opposite rotating vectors of half magnitude. So this is the principle of double revolving field theory, that any alternating uniaxial quantity can be represented by two opposite rotating vectors of half magnitude. Alternating sinusoidal flux can be represented by two revolving flux, each equal to half the value of the alternating flux, and these two fluxes are rotating in opposite direction with a speed of synchronous speed. As shown in figure A, the figure A is showing there is magnetic maximum flux which can be divided into two quantities A and B, and both are revolving in the opposite direction. So this is showing that the after some times in the figure 2 we can see figure B, we can see that after angle theta the resultant flux value will becomes 2 phi m by 2 cos 2 theta by 2, that is phi m cos theta. As the flux completes quarter cycle of rotation, the fluxes will become lying in opposite direction, so that the resultant flux will become 0. So now continuing with the rotation, after half the cycle the A and B fluxes will have the resultant flux minus phi m. So after the after the 3 quarter cycles in figure shown in E, the resultant flux again becomes 0 because both the fluxes rotate in opposite direction. So if we plot the resultant flux against theta limits varies from 0 to 360 degree, then we can get a curve shown in figure F. So figure F is shown here. In this figure we can see that flux is varying, first to maximum, then 0, resultant flux we are talking about, then maximum in the opposite direction minus phi m, then again 0, and then value is maximum. So this is all about the rotation cycle of maximum flux, how maximum flux is varying, phi m is varying with respect to theta. Theta is the space angle, how it is varying with respect to theta. So it may be noted that if the slip of the rotor is S, with respect to forward rotating flux, then its slip will becomes 2 minus S with respect to backward rotating flux. So we are having two fluxes, rotating fluxes, one is forward, the other one is backward rotating flux. So this is concept of double field revolving theory. Each component of two fluxes while revolving around the stator cuts the rotor. Each flux of two components while revolving around the stator cuts the induced EMF, and this produces its own torque. Obviously the two torques are oppositely directed, so the net resultant flux is equal to their difference. So the two component fluxes can be resultant is the difference of the two rotating torques. So we are having two torques, one is forward torque, the other one is backward torque. So the torque's speed characteristic is shown here. This is for forward torque, this is for backward torque. The speed varies from 0 to synchronous speed. So forward torque is varying like this, backward torque is varying like this. Again, power developed by the rotor, we all know that it is air gap power is shown by 1 minus S upon S into I2 square R2. This is for single phase induction motor. For 3-phase we multiply it by 3. The multiplication factor will becomes 3. If n is the rotor speed in rps, radians per second, then the torque is given by Tg 1 upon 2 pi n 1 minus S upon S I2 square R2. N is given by rotor speed is given by synchronous speed multiplied by 1 minus slip. So the air gap torque is shown here. It is shown as 1 upon 2 pi ns I2 square R2 upon S. The forward and backward torques are given by, as resultant is, the forward torque is given by this and the backward is given by this. And we all know that it is forward slip is S, backward slip is 2 minus S. So the negative value is there shown here and the forward value is positive. And we all know that total torque will be the difference of Tf minus of Tb. But Tb itself is having the negative term here. So the resultant comes out to be Tf plus Tb. So this is all about how the sinusoidal flux induced in the pulsating flux induced in the single phase induction motor can be made into two resultant flux using double revolving field theory, and therefore the torque developed can be to move the rotor of the single phase induction motor. This is all about this lecture. We will continue single phase induction motor in the next lecture also. Thank you very much. Thank you.